The lead plan of room specialists has found that using our new 101 billion toy, it will be apparently always before that try changes into a reality. On the remote possibility that it goes as arranged, the outing to Proxima B will expect near 20 years, so sensibly, it will be several years earlier before we can interest if there is certain life on that planet. The laid-out sails of whether we are truly alone in this universe get through the James Webb Space Telescope, which has discovered some astoundingly human things far away from Earth that lead us closer to the response. Our central goal forever past us has been uncontrolled all through every human action to such an extent that we have countless media works and speculations concerning this matter. Our wonder concerning our spot and wretchedness in the universe has been steady. It is saturated inside us to reliably search for a mate, regardless of how fractional we might be. We might get progressively nearer to the responses we really need. Anyway, are they truly the answers we are looking for, or are they simply really upsetting? Join us as we break down the latest revelation in the space of systems and planets on the excursion to presumably track down something we won't be prepared to see, lights far away. Educated authorities have tracked down what could be the most profound disclosure in history. Back in 2021, when the James Webb Space Telescope was planned to launch, an exceptionally interesting hypothetical request was raised about the capacities of our technology. The inquiry was whether later on our telescopes could distinguish artificial light on another planet, for example, Proxima B, the closest exoplanet to Earth. Proxima B, around 4.25 light-years away, was identified to be perfectly locked with a very super-permanent day side and night side, like our Moon. A hypothetical imaginative enhancement for Proxima B could move power and energy from the day side to the night side using photovoltaic cells that make power from starlight. Thus, in a paper with Manis Ving as one of the science specialists, it was shown that a huge grouping of the day side by solar chargers could be associated with future telescopes. Since JWST was further developed, it would permit us to extend our quest for artificial lights on exoplanets like Proxima B. Now, the reality that the James Webb Space Telescope did unequivocally that in 2024, using its higher mindfulness and greater degree of capabilities, is groundbreaking. The JWST might have tracked down the lights we were searching for and maybe flung us into another gigantic surge of human movement overall. We should plunge into the universe of planets and exoplanets to figure out how this was without a doubt even possible. James Webb's mission explores Proxima B and its secrets. Beginning from the outset of written history, individuals have considered the chance of the universe, what we are, where we come from, and where we go. These are ordinary yet amazingly inconvenient solicitations that humankind has attempted to answer. When we obtain mindfulness in the hour of astounding mechanical advancement, one considers whether we are any closer to noticing these sails. If you somehow manage to ask a scholar, he could say we are currently at level 0 of understanding ourselves in the universe. In any case, ask a space expert the same request and watch him take full benefit of his energy as he rushes to tell you the most recent disclosure individuals have made about the universe using their shrewd gadgets. These instruments, yet not given much thought by the general public, are directly an impression of human activity itself. We currently have the world readily open, and it's time we push forward and get the universe at our fingertips. One such method for doing this is determined by scientists and space experts through the technology we tackle. A specific making of that technology is now dependable for the new disclosure of what might be light on another planet light years away. Indeed, we're talking about the James Webb Space Telescope. The James Webb Space Telescope is the creation considered out of the tradition of human endeavors into space to address some ever-present questions. Are we the only ones out there? Where do we start? And where do we end? This infrared space science gadget has previously started looking out for these sails, not enduring the reality that at first you could get yourself asking what Proxima B is. Proxima Centauri b, or just Proxima B, is sometimes alluded to as Alpha Centauri b. It is a super-Earth exoplanet and orbits an M-type star. Super-Earths could perplex you, but don't stress. This text will settle all your consuming inquiries. Super-Earths are a class of planets that are more monstrous than Earth, but lighter than ice giants like Neptune and Uranus. They are truly one of a kind. They can be made of gas, rock, or even a blend of both, and their sizes can vary from twice the size of Earth to several times its mass. As for B, it is a super-Earth and an exoplanet, meaning that it circles outside the nearby planetary system. The primary possible proof of an exoplanet was found as early as 1917, though it generated pretty much no interest. However, confirmation came in 1992 with the first confirmed discovery, which left specialists paralyzed. Another exoplanet, first recognized in 1988, was confirmed in 2003. As of April 1, 2024, there are 5,653 confirmed exoplanets in 4,161 planetary systems. Of these, 896 systems have more than one planet. These prominent discoveries are surrounding an M-type star. To understand the M-type star, you need to sort out the red. Red is the smallest type of star in the main sequence, hence the name, in the interconnecting region of the Sun. Red midgets are by far the most common type of star found in the Milky Way. They have incredibly low glow, and since glow is one of our primary tools for planet recognition, red dwarfs are not so easy to see. These subtle stars have variable definitions and names depending on their temperatures and sizes. For instance, M dwarfs, or N-type main sequence stars, yield a maximum temperature of around 3000 K, thus getting their name. Concerning B, its mass is known to be similar to 1.07 Earths. Inquisitively, it only requires 11.2 days to complete one orbit of its star, contrasted with our 365.25 days. You can check the size of the star Proxima B is surrounding. It is staggeringly under the assessment of the entire electromagnetic range. The star has a total iridescence of as little as around 1.6% that of the Sun. Other than in the visible light range, its radiance seems to reduce more. It only shines 5 to 6% of the Sun's splendor, transmitting a much lesser amount of light energy compared to the Sun. Over 85% of its emitted energy is in red radiation, revolving around about 0.045 to 0.056 astronomical units from its star. Proxima B's discovery was reported back in 2016. You could ask why Proxima B, with 1 million stars, planets, and universes, is of such concentration. Well, there are a couple of reasons that add to the recognizable interest astronomers have here. Specifically, Proxima B is the closest known star to our Sun, and by definition, it is 4.2 light-years away. A big number to us Earthlings. In the grand plan of the universe, it is a straightforward blip. Subsequently, why Proxima B, our closest known star, is high up on the priority list right now is part of the triple star system called Alpha Centauri. Also, in spite of Proxima's radiance being unimaginably low, the system itself appears as quite possibly one of the most brilliant celestial bodies in the evening sky, just behind two others called Sirius and Copus. Anyway, the most dying thing about Proxima B is that it could truly be habitable, as it falls within the habitable zone. The possible results surrounding the star are ceaseless, and thus space experts have assumed the task of investigating the profundities and limits of the star's validity. That's where the James Webb Space Telescope comes in. The four crucial goals of the JWST are to look for light from the primary stars and worlds that formed in the universe after the Big Bang, concentrate on the universe's arrangement and development, sort out star and planet development, and focus on planetary systems and the beginnings of life. As the JWST continues its assessment of the said exoplanet, we draw nearer to the highest point of these missions, from searching for exoplanets to looking for extraterrestrial life. So what exactly is said? One could ask, taking into account that individuals have forever been an inquisitive species, exploring and getting into literally everything that moves and doesn't move. It makes sense that a mission like SEI appeared on such a vast scale. Imagine that God has composed an incredible, gigantic undertaking, yet with a hint of gold. We are tasked with being on the lookout for signals, more specifically, electromagnetic murmurs from human developments beyond anything we might ever imagine. SEI, short for the search for extraterrestrial intelligence, looks like the world's most high-stakes game of hide and seek, with our planet as the searcher and the vast universe as the seemingly endless hiding spot. It's one of those fields where specialists are like ADV Sherlocks, tuned into radio waves and scouring for that subtle, "We are not alone" signal. This enormous search began in the 1960s. Frank Drake, an outstanding astrophysicist, was among the first to recognize radio transmissions from the stars. It was a paramount moment. However, no outsiders appeared at his door. Now, however, as you might have guessed, looking for something this massive takes patience and can span many long years of work. At times, only a few conclusive alien signals have been found. Despite these efforts, the energy keeps on growing as the James Webb Space Telescope continues to inspect exoplanets like Proxima B. A whole field of hope is emerging. Will we accidentally find real evidence of extraterrestrial life? Or will we simply experience creepy signals right outside our capacity to fathom, giving us more questions than answers? The discovery of lights could mark the next part of humanity's timeless interest, where curiosity and advancement blur into one giant, exciting space story. So let's keep looking, hoping to find confirmation that we are not truly alone. The discovery of lights from faraway exoplanets, like those potentially seen on Proxima B, could be a remarkable step toward answering one of humanity's most significant questions. Are we alone in the universe? As the James Webb Space Telescope continues to inspect the skies, its discoveries will undoubtedly spark more conversations, examinations, and perhaps even challenges to our fundamental understanding of life, intelligence, and the nature of the universe. The ramifications of these discoveries extend far beyond simple curiosity. They carry the potential to reshape our philosophical and scientific systems. For instance, if we were to confirm that Proxima B or another exoplanet harbors some type of life, it would require us to reconsider our position in the universe. Could life elsewhere evolve in ways similar to our own, or would it present a completely new kind of existence? Would it follow similar transformative pathways, or would it challenge everything we know about life on Earth? Even if we fail to find direct evidence of intelligent life,